When you see a really stunning car roll by, what's one of the first things that grabs you? Besides the paint, I mean. For me, a lot of the time, it's the wheels. They've just completely changed, haven't they? From just functional parts to, well, these big design statements. They need amazing performance, sure, but also that flawless, almost artistic look. So today, we're doing a deep dive into the fascinating, often kind of hidden world behind these sleek, high-performance aluminum wheels, getting that mirror finish and that pinpoint precision. It takes some seriously advanced tech, incredible attention to detail too.
Yeah, our deep dive today, it's based on materials looking at eSCAR's solutions for aluminum wheel machining. And our mission, really, is to pull back the curtain a bit on the big challenges manufacturers face making these things, and then, discover how specialized tools and tech are getting over those hurdles, making sure we get both efficiency and that perfect finish we all expect on a new car. And if you look at the big picture, I mean, the aluminum wheel industry is just booming, rapid, sustained growth globally.
It's mainly fueled by, the constant demand for new vehicles, right? And consumers. They increasingly want wheels that are strong, light, sure, but also super stylish and high performance.
It is quite remarkable. And that growth just ramps up the competition intensely. Manufacturers are essentially walking this tightrope, always trying to balance aggressive cost cutting with the absolute need for superior quality. Because the final price of that wheel isn't just the aluminum cost, it's heavily, heavily influenced by the machining technology and how they actually produce it.
That's a really critical point, because these aluminum wheel manufacturers, they operate in such a fast-paced world. Precision, surface quality, cycle times, these things directly hit their bottom line, profitability. And they have to meet the auto industry's super strict standards, dimensionally and aesthetically. There's just no wiggle room.
So it begs the question, what kind of tools can possibly handle that? We're talking about tools that need to cope with really high cutting speeds, heavy forces, deliver super consistent performance shift after shift, and still give you that flawless, beautiful finish. And then you add the trend towards mass customization on top of that challenge. Imagine churning out hundreds of different designs, sizes, finishes, all with minimal downtime for changeovers. It's a huge operational puzzle.
Exactly. And that's precisely where companies like eSCAR come into the picture. They provide these advanced, cost-effective machining solutions specifically tailored for aluminum wheel production. Their goal seems pretty straightforward. Boost productivity, make the tools last longer, and get that superior surface quality consistently, even in these tough conditions.
And the real advantage, I think, of their approach is how comprehensive it is. Their solutions cover, pretty much the full range of processes. Everything from the first cuts on the outer and inner diameter to facing undercutting, and even the super precise drilling for valves, lug nuts, center holes. It's all integrated.
Okay, so given how fast everything moves and how demanding it is, one of the big bottlenecks must be tool changes, right? On the factory floor. So how does eSCAR deal with that need for speed and precision? Let's unpack their DTF quick change tool holder system. Sounds like it's designed for pure speed, stability, accuracy, especially for those automatic stations where consistent tool life is just vital. And the user-friendly part. Operators can clamp or release the tool heads with just one screw. That must slash changeover times.
Right, it does. But the real cleverness, I think, is in the rigidity, that dovetail face contact they use. It's not just about being fast. It's about dampening those tiny vibrations you can't even see, those vibrations. They can totally ruin a high-gloss finish. It's the difference between a wheel that looks okay and one that just pops under the lights. And the system's versatile too. Works with eSCAR's grip and ISO insert families, and you can use it with standard emulsion coolants or with minimum quantity lubrication MQL. MQL is quite interesting, actually.
Right.
It's not a flood of liquid, but this really fine, precise mist of lubricant, often better for the environment, and can help avoid residue before painting. So for you listening, this means a manufacturing line can switch between wheel styles or fix a problem incredibly quickly, gets new designs out faster.
Okay, that makes sense. Now, another key thing for that flawless finish, targeted coolant supply. You mentioned aluminum machining controlling temperature is crucial for getting that high surface quality, right? So the DTF tooling has a system built in to get coolant right to the cutting edge.
Absolutely vital. Precision cooling. But maybe the even smarter part is how it blasts away the tiny aluminum chips the second they form. This stops them getting recut into the surface. That's actually a common cause of those little flaws you only notice after painting. Super frustrating. Plus, it reduces heat buildup naturally and makes the tools last significantly longer, so it helps productivity and the final quality. For you, this just means a cooler process, a smoother wheel finish, fewer duds, longer lasting tools, all adding up to better quality and hopefully a more reasonable cost for the wheels on your car.
Right. And when manufacturers need the absolute best cutting performance, the top tier, eScar recommends polycrystalline diamond inserts, PCD. These sound serious, designed for stability under the highest cutting conditions. And they come in different shapes, geometries, like those 35-degree rhombic ones or full radius designs, sometimes the chip breakers. What do those do exactly?
Chip breakers. Okay, imagine peeling an apple and getting one long continuous strip of peel that gets tangled. Chip breakers are tiny, carefully designed bumps or grooves on the insert. They deliberately curl and snap those long, stringy aluminum chips into small, manageable pieces. Stops them tangling up or scratching the fresh surface of the wheel. Really quite clever.
Got it. So these PCD inserts, they're versatile then. Roughing, semi-finishing, finishing.
Yes, all stages. But here's where it gets really cool. They have special, bright-facing PCD inserts. These are specifically engineered to prevent microscopic porosity and tiny burrs forming on the surface after painting. This ensures the wheels meet those incredibly strict visual standards. No compromises. For you, this is basically the secret sauce behind that perfect mirror-like finish on premium wheels. Make sure they look stunning even after painting.
Okay, switching gears a bit. What about cost efficiency? Still need quality, but maybe more of a workhorse tool. There's a VNGU ISO 35 degrees rhombic insert. You mentioned ISO 35 degrees before. This one sounds like it's built for everyday production. 4 cutting edges. Positive flank and rake angles.
Exactly. And those angles are really important. Why do they matter? Well, think of it less like scraping the metal off and more like slicing it cleanly. These positive angles allow the tool to shear the aluminum with much less force. It makes the cut cleaner, reduces heat, and crucially stops the aluminum from sticking to the tool edge, which, as we said, aluminum loves to do. So this insert gives you better chip control, especially with high pressure coolant, longer tool life, excellent finish. But the big win is lowering the cost per part significantly. Zooming out, for you this means high-quality, stylish wheels can be made more affordably. Makes them more accessible.
Makes sense. And you can't forget drilling. eScar offers comprehensive solutions there too. A whole range for wheel makers.
Oh, absolutely. All those critical holes, center bore, lug holes for the bolts, the valve stem hole. These drills are designed specifically for that precision work, even doing back chamfering. And they come in different types. Solid carbide for rigidity, indexable inserts for economy, even PCD tipped for ultimate performance in life. Gives manufacturers the flexibility they need, whatever the wheel design throws at them.
Now let's dig into the materials themselves. The specialized cutting tool grades. This sounds like getting the absolute right recipe for the job. eScar's grades are formulated for specific aluminum machining needs, like IC20, that's an uncoated carbide for medium to high speeds.
Exactly. Think of it like having a whole team of specialized athletes. Each grade is optimized for something different. Need raw speed for a general cut. IC20 might be your guy. Dealing with tougher conditions, maybe higher temps, you might look at IC04 or IC07. Those are hard submicron carbides, chasing the absolute fastest speeds and best finish. ID5 with its polycrystalline diamond brazed tip, that's the champion performer. And they even have coatings, like on IC1520. That's a DLC diamond-like carbon coating. Helps extend tool life when you're really pushing things in aluminum. What this really shows, for you, is the incredible depth of material science involved. Optimizing every tiny aspect for different needs, maximizing efficiency, making tools last longer.
And maybe the most subtle thing, but sounds incredibly important, the secret to a really clean cut. Cutting edge quality and having polished surfaces on the inserts. So most eScar aluminum inserts are ground to be super sharp with positive geometries. And that helps prevent the aluminum building up on the edge because it's so sticky.
Precisely. It's a huge factor. Those unique grinding profiles they use are a significant advantage for getting stable, high-quality results. And yes, the polished top surface on the insert, that's critical. Think of it like waxing a ski. You want smooth flow. Here, it helps the chip slide off effortlessly. It reduces friction, gets the chips out of the way cleanly, keeps the cutting zone clear, and leads to a softer, cleaner cut overall. It minimizes that built-up edge, or BUE. That's where aluminum particles literally weld themselves onto the tool edge, ruins the cut, ruins the finish, fast. So that polished surface is key to stopping that. For you, again, all this micro-level attention to detail on the tool translates directly. It means that ultra-smooth, flawless finish on the wheel, preventing those tiny imperfections that would mean rework or scrapping the wheel entirely.
Wow. Okay, so if we kind of pull it all together, what we've seen today is how all these eScar innovations work together. From the quick change tool holders to the diamond inserts, those specially ground and polished surfaces, it all adds up to faster production, tighter tolerances, and those amazing finishes we just expect now on aluminum wheels. These often invisible bits of tech, they're really what make modern car design possible and affordable.
Absolutely. And zooming out one last time, what it means is Just better quality wheels for you, the consumer. More durable, much more visually appealing. And they're produced more efficiently, which helps manufacturers. It's just a perfect example of how this highly specialized engineering affects everyday products we use and see. Makes them better, makes them more stunning, makes them accessible.
So, as car design keeps evolving and that demand for mass customization just keeps growing, it makes you wonder, right? What other seemingly small, sort of invisible manufacturing innovations are going to pop up next? How will they fundamentally change the products we use and the industries making them?